Yeah, hello and welcome to the next lecture in OOP1, which is today mainly about operator overloading. We are currently in the 7th lecture, meaning that there's just one left after today. So next week then we finish the lecture part with templates and some further selected topics in object-oriented programming. Yeah, before we start with the content for today, a recap as usually. Last time we've heard about casts and just a quick comparison between what we've learned about C casts and then C++ casts. The main advantage of C++ casts is that they are checked by the compiler, so they fail at compile time, which is an advantage because the other ones, the default C casts fail at runtime, which could be a problem. We have many different cast types in C++ depending on the use case. So we have clear intentions then when to use which type of cast, which is not the case for C casts where we just have one cast and then the intention is not always clear what we want to do or what the programmer, if we work in a group, wanted to do with this cast. Further advantage is that we can easily find such C++ casts in the code as compared to C casts. Yeah, just as a hint, as we mentioned last time, if possible, use the C++ casts, at least for the practicals. Yeah, then a short recap of Smart Pointer. We just have seen a very extensive example about shared pointers and weak pointers in the practicals. So smart pointers are basically just a wrapper around a raw pointer and provide us functionality like that they throw exceptions and avoid some other pitfalls. And a further advantage is that they destroy themselves at the end. So there's no need for further memory management on our side. Yeah, there are three types of smart pointers, which are the unique pointer, the shared pointer, and the weak pointer. And if we want to use them, we need to include memory. Yeah, that's so far the recap for today. Today we have one large topic, which is operator overloading. But before that, we have some smaller topics that, we need to discuss before we come to operator overloading, because then operator overloading uses those concepts, which are name conflicts, method chaining, and visibility and friends. And we start with the first one, which is name conflicts. So we have a little example here with a class cat, and we have here an unsigned age as a member, and then here a constructor which takes an unsigned age, and then it sets age to age. The compiler doesn't give us an error, but a warning that, we have here a value that we assign to the value itself. So, which is basically the local value here, the local variable age, and we set just the value of age to itself, which is not really what we want to have, because I think what is meant here is that we want to set the age to our member age. What can we do to prevent such name conflicts? Do you have an idea? This is actually a keyword which we want to introduce you, but there are some further solutions we could do, but we come to this in a minute. Yes, correct. Thank you. So the first solution could be, use the naming conventions with the member variable as age underscore. Are there further solutions besides this keyword?
There's one more.
The name of the class? this is a solution I didn't prepare. So there's one further solution. Any ideas?
So the second one I would not recommend because it's still a bit dubious to read.
Yeah.
What is it?
Yeah, it's the initialization list that we can use, but here we have, so it would work because this age here is the member and this one is the local variable, so that the parameter we get. But yeah, as David just mentioned, it's not a solution we would recommend because yeah, it's not that easy to read, or if we read it, it's not that obvious what happens here. Yeah, but the third solution that was already mentioned before is to use the this keyword, and the this keyword is basically a pointer that points to the current object. In this case, we are in the constructor of the cat class. The this keyword points to the object that is currently created in the constructor. So if we have a pointer here, we could, for example, store it in a cat pointer because it is a pointer pointing to the current object. So it is a cat pointer. And after that, we could say current cat pointing to age. So you see it age. And then we could say, yeah, we use this age as local variable and overwrite our age in the current cat. So this would be then the member age. But
again, a bit complicated?
Yes, sure. Thank you. It's a bit complicated, but I think it gets you an understanding of how this works, the this keyword. So there's for sure an easier or shorter version by not creating a further local variable, in this case, this current cat pointer variable. We do not need it. We can just say this pointing to age, and then age is overwritten by the parameter age. So in this case, it's clear this is the pointer to the current object. The member age, we are overwriting it by the value from the parameter age. So this is just the short version of the left side, and this is the preferred and shorter way in this case. Okay, so a few further words to the this keyword. As I said, it's a pointer to the current object, and it's for sure just available inside class methods because, as I said, it points to the current object. I can't use this, for example, in the main method because there is no current object I am working on, so I can just use it inside class method. Yeah, if I dereference this, then I for sure get the object itself. I can do this, for example, to return a reference instead of a pointer to the object. It is useful, as we have seen, to resolve naming conflicts, to make sure which age in the previous example is meant, but we can also use it to return the current object from a method inside a class. To use method chaining. Method chaining is something we will see in a minute. Is a new concept, and we can also use it to pass it to other functions as arguments. Yeah, we will see this in this example, how this works. So in this example, we have a forward declaration of a class player, and then we have a class team, where we have a vector of player pointers as a member variable, and we have a public method which is named addPlayer. It takes a player pointer, and what it does is it adds this player pointer to our vector. And in the player class, we have a join team method that takes a team as argument. And the idea now is to call the addPlayer method of this team and add the current player object we are working on, so to say. So, for example, if we look at the main method, then we have here a team called myTeam. We have two players, Walter and Jesse, and then we want to call the join team method of Walter and then of Jesse, passing the team we created as argument. And then here in the join team method, we want to add the player we are calling the method on to this team. So in this case, in the first step, we want to add Walter to the team, and then we want to add Jesse to the team.
So basically they are assigning themselves to a team.
Yes, correct. And how could this work? With the this keyword for sure, we are calling the team.addPlayer method. So we call from the team we get here as parameter the addPlayer method and pass the current object as pointer in this case. So we just say this, which is a pointer to the current object. In the first case, it's a pointer to Walter. In the second case, it's a pointer to Jesse. We are passing it to the addPlayer function, and then we add this pointer to our vector. So this is an example how the keyword this could be used as an argument in this case.
So whenever you are facing the situation where you somehow need to access the class you are currently in, then this will do the job for that.
Yes, correct.
Another question to you, why do we need this player here, this forward declaration? Any ideas? Yes? Yeah, so if we would not do that, we cannot use the player here because it's defined afterwards. Yeah, so it would result in a compiler error. So we need somehow tell the compiler there is a player class. We will implement that later, but there is it. So for now, you can pretend that there is a player class. Any questions to this? This is a very important topic, especially
Yes.
for operator overloading. That's why it's essential to understand what this is.
Okay, so if there are no questions to this, we come to that.
To that, yeah. Not really that, but to method chaining. Method chaining is, as you said before, one way to use this. Let's talk a bit about koalas again, or at animals. I was in Australia last year and I saw some koalas, and they really eat and sleep most of the day. So I think they sleep about 20 hours, and then for 4 hours a day they are eating. So basically their daily routine is sleeping, eating, sleeping, eating. Very funny life, at least in my opinion. When we want to implement that, we could do something like this. So create our animal class, create two functions or methods, the eat and the sleep. In this case, they are just printing something. And then we call animal, so we create our koala. We can then call eat, koala sleep, koala eat, koala sleep, and so on. That's basically what they are doing. But
is there an easier way to do this?
There is one easier way using this method chaining. So method chaining is when you call it like this. So you can say koala.eat, .sleep, .eat, .sleep. So basically you don't have to call them in new lines and always write koala.sleep, koala.eat, but you can somehow chain this together. And this can be done again with the this keyword. So there's one modification. We are always returning an animal reference, and we return the dereference this pointer. So basically when we call eat, it's the same as before. This is printed, but in the end we are returning this object, yeah? So the object itself, the koala. So the return value of this eat here is the koala, and we can call on this koala sleep. The return value of this sleep is the koala itself, so we can call eat, and so on and so forth. So sometimes it makes sense, especially I think in web programming, it's a very common way to do this method chaining. it makes sense sometimes to do some tasks for the same object and combine it into one line. It's easier then to use that. Yeah.
So one question to that, could I also use, or here you return a reference, right? Could I also return an object instead of the reference to the object?
So you mean you can, of course, also return this as a pointer then, but of course you have to consider that here.
Okay.
Yeah. Then you have a pointer to the animal, but it would work also. But usually references is a bit more common and easier because then you just need the dot here to access them.
But here the reference is necessary because otherwise it would get copied, right?
In this case, yeah.
Yeah.
Of course,
Okay.
yeah. It would get copied, yeah.
And this is something we do not want here because after calling eat, we want to call sleep on the same object, right? And not on a copy.
Oh.
Yeah.
You're right. That's true. You got me.
Yeah. To make sure that we always work on the same one object. Yeah.
That makes sense. That's why we need the reference to the same one. Yeah.
Okay.
So, yeah. Okay, one quiz for you. Basically, I think it's pretty much the same. It's a koala again. We have our animal class with an ID, and we have a getRef method inside and the print method. The question now is, what is the output? Okay, so we're creating the animal, the koala, with the initial ID of 2. Then we call koala.getRef, which returns a reference to an animal. We store that reference to the animal and then print, or call the print method.
So already 17 answers.
Yeah, a few more seconds for you to decide. Yeah, we reached the 20, great. So let's see. Yeah, you spotted it.
Great.
Okay, there is a compiler error inside.
But where?
Where is the compiler error? So this is the error when we want to try to compile it. Where's the compiler error? Yeah.
This is a pointer and we want to return a reference.
Yeah, this is a pointer, so we have to dereference that to get a reference or to be able to return a reference then, and then it would work if we write it like this. Great. Okay, that was our short journey to method chaining. Last small topic is again kind of a preparation for operator overloading.
Yes. It's about visibility and friends. Friends,
yeah.
Okay. Yeah.
Friends in object-oriented programming.
Yes, correct. So visibility, just as a recap, you've already heard about it. We've learned what public, private, and protected mean. And yeah, friend also has to do with this visibility. So in this example, we want to access private members from outside the class. So we have here private members like name and power, and we have here a print player method outside of the class. And we have here a player reference, and we want to access name and power with the dot operator. And this is for sure not possible because, outside of the class we cannot access private members, but just public ones. But there is a way to tell the compiler that print player in this example, this method, is a friend of the class player. Then it's possible that print player can access protected and private members of this class. What we have to do is to declare this method print player with its signature here. So this prototype void print player, player reference P, similar as we have it here in the implementation, but with the keyword friend. So in this case, print player is allowed to access the private members of this class. In this case, the code would compile and the output in this case would then be Harry 20.
So friends can basically access private members.
Yes.
Maybe also as in real life, my friends are allowed to use my private, something in my apartment.
Yeah.
But not everybody, only my friends.
So for all other methods, except the print player method, it's the same as before. They're just allowed to access the public methods and members of a class. Okay, so if class A is a friend of class B, then class A can access the private and protected members of class B. In the example from before, we've just granted access to one specific method, but as you can assume, we can grant access for whole classes. So we can say class A is a friend of class B, then the whole class gets access to the private and protected members. So therefore we use this keyword friend, and as we said, it's for all other classes and methods, they are not allowed to access the private members, but the ones that got declared as friend. And when is it useful? If there are some specific methods or classes that should get access to private members, but the others don't. So here a further example where we want to add a whole class as friend. So in this case, we have a player class and we have a team class. And again, here we want to access private members of player, in this case name and power, from the team class. And this wouldn't be possible without a friend declaration because, we can access just the public members and methods. But by declaring the team class as friend, the whole team class is then allowed to access the private members of player. In this case, maybe you've seen it, compared to the code before, I need the forward declaration, again, in this case of team, because I use team here for the friend declaration, but it's not yet implemented. I just tell the compiler there is a class friend, which then is implemented afterwards. Yes?
I have a question. If class A is friend of class B and class B is friend of class C, is class A friend of class C?
Very good question. We'll come to that in a minute, but no, it's not. Okay, so a few more details about friend. So friend gives classes or methods access to the class, and there are not only advantages with this keyword because it somehow breaks the encapsulation, so the data hiding, because the keywords for the visibility with private, protected, and public, they make sense. So if we use then friend for all or many classes, then we somehow break this encapsulation thing. So just use it if it's really necessary. Okay?
For operator overloading, it's sometimes necessary. We will see that.
Yes.
But please be careful using it. If you submit your assignment 2 and in every class has 10 friends, then it's most probably you will get a point deduction because this is
maybe
not
there's
what
then
is meant.
an issue with your design. Yeah. Okay, so now we come to the question from before. So friendship in C++ is not symmetric.
In
so,
C++. In
yes.
real life, it's different, maybe.
Yeah, maybe different, but yeah. At least in C++, it's not symmetric, meaning that if A is friend of B, then B is not automatically friend of A. Okay? The question from before, it's not transitive, meaning that if A is friend of B and B is friend of C, A is not automatically friend of C. Okay? And it's also not inheritable, meaning that if A is friend of B, then A is not automatically friend of all the derived classes of B. So if I want to have a symmetry or transitive, then I need to declare it wherever I need it. So I would have to say A is friend of B and B is friend of A. I have to declare it in both classes, vice versa. Okay.
Okay, that was it already for our prior topics.
Are there any questions so far to those topics we just introduced?
So friends and this keywords are essential now, and we will use them for operator overloading.
Which is the next topic and the largest topic for today. Yeah, operator overloading was already mentioned, at least in the practicals today.
I think we heard it quite often already. It was always this mysterious thing, what can happen in the background. Let's see what it really is.
It's actually a cool thing, and we start with a small example to see why and where it is useful. In this case, we have, again, a player class with a power, and we have in our main method two player objects, George and Fred, and we somehow want to compute the combined power of those two players. There are for sure many ways to do this. For example, we could call the getter method for power, so get power for Fred and for George. Then we get the power of each player and we could sum it up. And we then have the combined power, which is 24. There are for sure, there's for sure a second solution. I could write a method that calculates the power of two players, which is in this case the add power method, takes two player references and also calls the getter of A and B and returns it as an integer. I call this method here and again I have then the combined power, which is 24 again. But wouldn't it be nice to have a solution like this, where I just call George plus Fred and then get the combined power of 24? Would be nice, but out of the box, the compiler is not sure which values are to add it up, because in this case it's quite obvious because we just have the power. So George plus Fred we would assume that it's just the power values that should be summed up. But imagine that there are further members, and then it's not that obvious which values should be summed up if I say George plus Fred. So this is not something the compiler does for us. So in classes that we write on our own, we have to specify what the compiler should do if we, for example, sum two objects from this class. In this case, for sure, the compilation would fail because the compiler doesn't know what to do with George plus Fred. Yeah, but there for sure is a solution, which is the operator overloading. In this first example, we use the plus operator because we want to sum up the values of George and Fred, but for sure there are further operators we will see in a minute. And this is basically a method within the player class where the summation, so to say, for George and Fred is implemented. In this case, I have the power of George, how this all works and how the syntax works. We will break it down in a very detailed version in a minute. But yeah, we just take the power of George and the power of Fred, sum it up and return it. And in this case, it would be possible to just say George and Fred, and then we would again get 24, which is in this case a very nice version of this example.
So basically, we can now decide what George plus Fred will do in the background when they are called like this. And we implement that in this operator overloading function. But it looks a bit strange, to be honest.
Yeah.
There's a lot of new things, so maybe let's go through that step by step what that means.
We'll break it down in detail. So the first thing is we call George and Fred and use the plus symbol between them, so the plus operator. So in this case, this plus is the operator. For sure, this can be other operators. We'll come to that on the next slide. This could be the minus, the multiply, the divide, but also other operators. And on the left side of the operator, in this case, it's an object of the type player, and on the right side, it's also an object of the type player. So we refer to this on the further slides, on the next slides, with left-hand side and right-hand side. And for sure, this must not be two player objects. It can also be a player and an integer. So I could also say I want to override the operator plus for a player object and an integer. So for example, that I can say George plus 10 to add, in our example, the power 10 to the power of George. So it's up to us what or which types we want to use in this case. So in this example, we have on the left side and on the right side the type player. So why do we implement operator overloading? We can modify the behavior of operators. So in the first example we've seen, we modify the behavior of the plus operator. We implemented it in the example as we would assume how it works. So we just sum up the two values. But as David mentioned, it's up to us how we implement it. We could also compute the subtraction. So player A minus player B, the power.
Yeah, so
wouldn't make sense, but it would be possible.
Maybe when they're fighting each other.
Yeah, okay. So George plus Fred in a fight would be first minus second power, something like that.
Yeah.
Would be possible, but maybe not that obvious, but would be possible. So as I said, it's possible to overload the arithmetic operators like plus, minus, multiply, divide, and so on, but also logical operators like the logical AND and the logical OR to modify the behavior for our player class, how the player class would behave if I use it on one side of the logical AND operator. I could also overload the bitwise operator or the comparison operators, how, for example, the player or what's the result if I compare two players with the equal operator. Then I can also overload the member and pointer operators. So for example, how to access a player. If I have for example, array implemented as a member, then I can overload the array brackets, so to say. And also the assignment operators. We'll come to that in detail also in a few minutes. So I can also overload the assignment operators and also the assignment operators in combination with the arithmetic operators. Yeah, so as I said, we can use operator overloading not only for 2 players on both sides, but also a player and an integer. But we can also use integer and player. So we can do it with both sides. So the important thing is that it's just possible for user-defined classes, at least if they're at one side of the operator. So it's just possible to overload operators if there is one user or a user-defined class on one of both sides. I can't do it for characters, integers, float, and so on if they're on both sides. So I can't overload the plus operator for integer plus integer, which is predefined. Integer plus integer, we know what the result is, and we can't overload that. But at least if there is a user-defined class on one side, it's possible.
And it wouldn't make really sense to overload the integer plus integer.
Yeah.
That would confuse everybody, I think.
Yeah, sure. Okay, so let's come to the syntax. How does it work? We have seen an example, but now to the syntax in general, we have the return type. In our case, from before, we returned an integer because we wanted to combine the power values, which are integers in our implementation. So the return type for sure is then an integer. But this could be different. I could return a double, a float, or also a void, or I could also return a player or a player pointer, which we will see in a minute. Then the operator followed by the symbol, so operator plus, operator minus, and so on, and then some parameters. In our case from before, there was just one parameter. We'll come also to that in a minute, how this looks like, but it could be the case that we do not have parameters at all for some operators. We will also see that. Okay, so back to the example from before. We had 2 players, George and Fred, and we want to sum them up. So we want to overload the plus operator. On the left side, we have the player object George, which is in the method, in this operator plus method, the this. So the left side of the operator is always the object that is calling the operator overloading method. So if we here use the this keyword, this is the left side. So it's a pointer to George. And then we have the operator, which has to be the same one as here. So it's the operator plus. And then on the right side, we have, in this case, again, a player object. But as I said, could also be another type. In this case, it's a player. So the right side of the operator is handed as argument to our operator overloading method. So in this case, we have a const player reference, and we call it RHS, right-hand side, could be any name. Yeah, and inside of this operator overloading method, we can do whatever we want. In this case, we want to compute an integer somehow. Yeah, in this case, we want to call, or we want to add to the power of George, which we call with our this pointer, the power of George plus the right-hand side object, which is the Fred object. It's a reference to Fred and the power of Fred. So we then get the summed up value of the 2 powers. And we return it. So the result then is an integer, and I can do whatever I want for sure with this integer. For example, I can store it in an integer variable, or I can print it out, or whatever I want.
So I think this is maybe the most important slide.
Yes.
To understand operator overloading.
Yes. With all the necessary details you need to know.
There are all the components. Let's maybe sum it up once again, because it's so essential. The magic behind is that when you write it like this, C++ knows that this method is called. And this is, in the beginning, I must admit, a bit tricky to understand. What it's always calling the George, so you can think of it like George operator, so calling the plus operator of George, then you're inside this George class, yeah? George is referred by this. And the second thing, which is after the plus, so the right argument, is then the argument here on this method. Does this make sense? Because this is really essential.
Can I have multiple operator overloads? Like if I have a plus one time on the right side, I have a player and another time an integer?
Yes, so the question is, can I have multiple operator overloadings? Yes. Same with every other method, you can use the same method name with different parameters. This works also for operators.
Can I have, like, assume George is a player, but Fred is from the class animal? Is this possible?
Sure.
And is then every time the left-hand side class called?
So yeah, the question is, if the left one is a player, for example, and the right one is, for example, an animal, does it still work? Yes, it works. It's again the George, so the player is called. The player is again the this, yeah, so George in this case. But then you have to implement an operator overloading where this argument here is an animal, and then it would work. It wouldn't, so if this Fred here is an animal and you have an implementation like this, you will get a compiler error because there is no operator overloading for a player and an animal.
But to combine those two questions, you can for sure have this method here, where we add a player with a player. Then we could have another method where we add an animal to a player, and we could have another operator plus method where we add an integer to a player. So three different operator overloading methods, with different right-hand side object types.
Okay, so the question is, if you implement it in a base class, you mean, right? Does it also affect the derived classes? It affects the part of the base class, yes, but you cannot use it with the derived classes as far as I know. Do you have more information on that? No, so I think you cannot use it. It makes no sense because it's not implemented for the derived class. You can only use it for the base class. It depends if it's friend, yeah, of course, yeah. But as long as you have not implemented it in the derived class, I think it's not working. Yeah, only works for the base class. Yeah. There was one more question.
Can we implement it for 3 objects?
So you mean George plus Fred plus Ron?
Good question.
Very
Tricky
good question. Yeah.
Maybe let me just explain one more thing. I will come to that very soon. We have also seen that there is a return type. The return type is an integer. So the result of George plus Fred, so the result of basically this operation is another value, object or whatever. Yeah? And then we can store this result with this equal sign into an integer. If we would have one more plus and then one more object, as hopefully you are also calculating, you're not calculating three objects at once. You're first sum up 2, and then this is a result, and then sum the next one. Yeah? So you would not need it.
Yes, so it's not needed because it's, for example, the same as with 3 integers. If you have integer plus integer plus integer, so there's no special rule for adding 3 integers. You just need the rule for adding 2 integers. The first and the second one are added. The result is an integer plus a third integer is then one further operation with just 2 integers. And it's the same here. So as David mentioned, in this case, we would have as a result an integer. And then if we have plus another player, we would have the plus operator integer plus player, which is in our case not overloaded.
Yeah.
Because in our case, it's just the other way around. Player plus something. In the example from before where I mentioned player plus animal, player plus integer, the player in this case also always has to be on the left side with this version we've presented you so far, where we then have the operator overloading in the player class. Then player always has to be on the left side. Okay? But we'll come to that later, where we switch it around and have also, for example, integer plus player, which is also possible, but not with this code so far.
Okay, I think we can continue.
Okay.
Now.
So the next thing we want to do is to change the return type. So in our previous example, we returned an integer as a result. But now we change the return type of our operator plus method from integer to player pointer, meaning that after adding George and Fred, we won't expect an integer, but we will then get a player pointer. After that, for sure, we can store it in a player pointer variable, in this case Ron, and then we do something with Ron, which is the third new player, which is the result of the summation of George and Fred. How does this work? So in this case, the right-hand side is also the same as the left-hand side from before. So we have on the left-hand side with George the player, so we are in the player class. So George is calling the operator plus method, and Fred is the argument. In this case, again, the player reference, right-hand side. But now our implementation is a little bit different. We compute a new power, which is again just the adding power of this from George and from the right-hand side from Fred, but then we create a new player with this new power and return this new player pointer, which is then, as I said, stored in this variable. This also works, as you see, the result is then the same because we call the getPower method of Ron in the end. But now the implementation is different because the return type is not an integer anymore. Yeah, and this is something David mentioned previously. This is basically the same as if you would call operator plus as a method as you know it from any arbitrary method by calling with the dot operator on the left-hand side on the George object this operator plus method, which is basically just this method here, and passing as argument the right-hand side, which is Fred, the player in this case. So it's pretty much the same, but for sure this is the more intuitive and the preferred way by just adding George plus Fred.
And I'm pretty sure you already used operator overloading. Maybe you didn't know it, but you already used it. Let's see where you used it already.
Yeah. So all of you used it in such a way where you have multiple strings and you added strings by using this plus sign. So we have the first string plus the second string plus a third string and so on. So in this case, we add the first to the second string. And what happens here is something we show you in a very simplified way. The string class also somehow overloads this operator plus by taking as right-hand side object for sure a string, because we on the left-hand side we are in the string class, we have a string object, and on the right-hand side we also have a string. So here right-hand side string, and what happens here is then a new string is created by appending the right-hand side string to this left-hand side string, which is the current object we are working on, which has the string as member, so to say. And the return value is then a string, because we want to return this new string, which has the two strings appended. And this is how this implementation looks like in a very simplified way.
And this is basically what your question was before. Yeah.
Because
so first the OOP plus is calculated. Then I have the result OOP is, and then there's a second operation OOP is plus ... This is then the second operation, but you only need one operator for that.
Yeah. So now we've seen this for another class than just the previous one we have seen with this player. So this is now how string uses this operator plus, for example. Okay. So for binary operators, we just see some further examples how this works. So in this case, the plus operator again, we have, I think, the same as we've seen so far. The player class, we have this operator plus returning an integer as result return type, and it takes a player as right-hand side and calculates somehow the power, in this case just adding both power values and returning them. So I can call George plus Fred, similar as we have seen before. And for the next example, we overload the multiply operator. We for sure can do this for both operators. So it's not only possible to do it only for one operator, so we can overload multiple operators in the same class. So in this case, we extend the player class with this multiply operator, and this multiply operator should also return an integer as a result, takes a player as right-hand side, and then should multiply the power of the left-hand side object with the power of the right-hand side player object. So in this case, George is the left-hand side, again multiplied with the power of Fred, as we would assume if we multiply George with Fred. So the result would then be power of George multiplied by power of Fred.
So these are the binary operators. We now know them, but there are more operators than just binary operators. Binary means there is a left side, a right side, but we also have operators where there is only one object.
Yes, and as I've mentioned before, there are also operator overloadings where we do not have a parameter, which we will see here for the unary operators. And we now look at an example for overloading the pre-increment operator, the plus plus operator. And you know it from, for example, integer values. If you say integer plus plus, there is no right-hand side. You just say integer variable plus plus. So we do not have a right-hand side here for this unary operator, and therefore there is no right-hand side, so there is no parameter in this case. But we want to do something like this: player object George pre-increment plus plus. But what should happen? In our case, we want to increase the power by 1. So we overload the operator plus plus without parameter. The return type in this case is void. So if we just want to increment the power but do nothing further, we do not expect any result of this operation, then void is enough. What happens inside this method is just incrementing power. But there is also an extended version of this pre-increment operator implementation, where I do not return void, but a player reference. And then I say power plus plus, and return this with a dereference of this, so I return the player object as reference. Why would I do this? So then I can again say plus plus George. What would happen? The power of George would be increased by 1, similar as on the left-hand side of this example. But then I could also do something like this. I could say Fred is plus plus George, because the result of this incrementation of George is a player reference, which I could then assign to a Fred, which is a player variable, for example. So I can use it as you know it from integer variables, for example, where I can combine the pre-increment, for example, with an assignment. And I could also do something like this. I could say plus plus George, so I would increment the power of George, and as a result, I get the reference to George, and then I could call on this reference the getPower method, for example, and I would get the increased power value for this call then. So I think the right example is maybe the preferred way, because I have more options than to use this operator plus plus.
The second one, so this Fred is equal to plus plus George, is a bit tricky because
Yes.
you're returning a player
Yes.
reference. So basically you're overwriting the Fred
Yes, sure.
with George.
Sure.
Yeah.
Yeah. Okay. Then we also want to have a look at the dereference operator. So it's also possible to overload this dereference operator. This could look like this. We have a smart player class, maybe something similar to a smart pointer, where we have a player pointer as member, and we overload this dereference operator of this smart player class, which should then return a reference to a player. Yeah, and then I could say I return the player, my member, and I dereference it to get the object, which I return as a reference. So this could make sense, for example, if I have a smart player smart, which I initialize with a player, George, and afterwards I could do something like this. I could say I want to dereference my smart player. So then this dereference operator is called, where I then get a reference to player back, where I can then call the getPower method of player. So this is just an example of how the dereference operator could be overloaded, but yeah.
Have you ever overloaded the dereference operator in practice?
I don't think so.
Yeah, it's
Can't
so with many operators, it's doable, so you can overload them. In many cases, it's not really practical to do.
Okay.
Okay, so we heard a lot about different operators and overloading. That's the first quiz for you.
So here we have the player class implemented as before, but the interesting part is here in the main function.
So we can assume it's the same player we are talking about now for a few minutes. Creating two players, a George and a Fred. And then we want to compare them.
Yeah, as mentioned before, so out of the box, if we look at this if statement here, George equals Fred. So the compiler out of the box wouldn't know what to do because, how to compare two players? When are two players equal?
So the question now is not what is the output?
Yeah.
It is which possible operator overloading method is called.
Yeah, correct. And then we have cout with
Yeah.
equal in this case.
Okay. Let's see.
Okay.
What was your answers?
Yeah, great.
Okay.
Yeah, so the correct answer is that this operator is called where the right-hand side is a player and the result of the operator for sure is a bool, because the Boolean true or false is the result of a comparison if they are equal. The other ones are wrong because here in this case the right-hand side would be correct, but the result is a player reference, which is in this case not correct because, yeah, this comparison operator should return a Boolean. Okay.
Yeah, we also saw that already back in lecture 3 when we had this time example and we were talking about copy constructor, default constructor, but mostly about the copy constructor, which was back then a huge problem for us to have so many different ways when copy constructor is called. So when we create here a time object, then copying by creating a new one, by assigning a new one, we're using this, this operator, but also when we called functions or methods and then we handed over an object as arguments. And then we had this interesting line here where we said we have T3, which is an existing time, is equal to T2. And we said it's none of the above, so it's not the copy constructor, not the default constructor or whatever, but it still works if there is an implementation. Now we know the assignment operator is called. So there is an implementation, or there must be an implementation in this time class. Looks basically like this. So when I have an existing object on the left side and this assignment operator, then this method here is called in this time class. It's again, this object is the T3 because it's the left object. And the right object here, the T2, is my argument here. And when I do it like this, I can basically set the values of T2 to the, or set all the values from T2 to T3. And I can also do this kind of method chaining because then I could also write the result if I want in another one or whatever. Mm-hmm. Yeah, so this just as a for completeness, lecture 2, we had this small kind of, yeah, I think we never explained it in detail. Mm-hmm. Now you know it's just the assignment operator. And the difference to the copy constructor is that at the copy constructor here in this line, the left object does not exist. And here the left object does exist, so we can enter the class, we have this object already, and then we can, again, implement here what should happen if I write it like this. Mm-hmm. Yeah, thank you. We can also, of course, delete it. Sometimes, in many cases, actually, it makes sense to save you from troubles. When you think you write it like this and you say, oh, okay, it's just a copy constructor. I already implemented a copy constructor, it works. You can explicitly delete it. And this reduces the risk of using the assignment operator by mistake, because if you explicitly delete it, you will get an error like this, because the assignment operator, there is a default implementation. Mm-hmm.
Yeah, and the default implementation looks like this, right?
The default implementation does not look like this because it doesn't know what to do. Yeah. So in many cases, it would make sense to delete it, or in basically every case, I think, would make sense to delete it or to implement it.
Okay. Yeah, so as you can see here, this is not an error. So it's an error by the compiler, but it's not an implementation fault.
Yeah.
So it's something that we sometimes want to have. So we want to avoid that we have statements like this. Okay, so the next operator we want to have a look at is the output operator with these two smaller signs. You already know, I think, since the first lecture. And yeah, we can also overload this output operator. Why does it make sense? Because then we can do something like this. We can say we have a player object, George in this case, and we then can say cout George. By default, the compiler doesn't know what to do because what of George and in which format should it print. So per default, this output operator is not implemented for custom-defined classes like player.
A very nice error message. So
Yes.
you can see on the first hand what's the problem here. Yeah. So if you run into this problem, maybe it has something to do with not implemented the operator overloading correctly.
Okay. Yeah, so how can we override this output operator? It's not the way we have learned in the past 20 minutes, because on the left-hand side of this output operator, we have the standard cout, which is not a custom-defined class. So we can't go into the cout class and then write our output operator. So there's another way to do it for types on the left-hand side that are not custom defined. So this can be, for example, the standard cout or an integer or other not custom defined classes. And on the right-hand side, in this case, we have a player. Yeah, and the implementation looks like this. We have our player class as before with the power as member. We have our main as shown before with this cout output operator George. And here we have the implementation for our output operator. So we overload this output operator with two parameters now. So there's not just one parameter, which is the right-hand side, but there are two parameters, which is the left-hand side and the right-hand side. The left-hand side is the standard out stream in this case, which is the standard cout, which is an O stream. We pass it as reference, and also the player we pass as reference from the right-hand side. And then we can do whatever we want. In this case, we want to say out, which is the variable of the O stream, which is the standard cout. And there we want to say, we want to output power and p dot power, which is the power of the player George in this case. And for method chaining, again, we return then out, so the O stream as return type, then we could concatenate it with further such statements. And as you can see, this operator overloading is now not implemented in our player class because it does not really belong to player, but it's implemented outside of the player because, player is just the right-hand side, but not the left-hand side in this case. Yeah, but there's a problem still. In this case, we want to call power from our player, but we are outside the class. So in this case, we cannot access the private member. Error by the compiler. What could be the solution to get rid of this error? Yeah, great. So now we can use the keyword we've learned today. We can use friend by declaring this operator overloading method of this output operator as friend. As you can see here, I add friend, this signature of this method here, And then we have here the access to the private member power in this case. And now it works. And now I can do something like cout and a player object, which then outputs power colon 10 in this case. Yeah, then there is another solution by implementing it directly here without just declaring it as friend, but also adding the implementation here. It's kind of similar like header files and CPP files. Yeah, so here the implementation is directly in the player class. What do you suggest?
So this is a bit tricky again, because you're thinking you're inside the player class and you can use this as the left object, but actually the left object is this out here. So I prefer the other way because it's a bit more obvious what's happening there. But yeah,
I think.
What do you prefer?
I think I'm on your side. So I think it's a nice separation here because it does not really belong to the player class, and we declare it as friend, but the implementation is outside of it. But also the second solution works. Yes?
Why should we implement something like this when we can also write a function like player.getString or something like that, or print info?
Yeah, I think the answer to this question is what we have shown as motivation for operator overloading on the first step, where we wanted to say George plus Fred. We do not want to say George get Bauer plus Fred get Bauer. So we want to have something like this. We want to output objects. We want to add objects. We want to multiply objects. And in this case, for the output operator, it's just an output. But in some cases, the calculation could be a bit longer, so to say. So adding two objects is not necessarily just adding two values as member, but there could be some difficult calculation between multiple members and so on.
Yeah. So let's say George is not just maybe the name what you want to print, it's his whole biography, including you have to do some calculations, adding some stuff together. This would need that you write it every time when you want to print it out. Call this function here or implement a function. Of course, a function would also work, but this is in many cases a bit the easier way.
Okay, so coming back to our first example with adding two players, in this case George and Fred, where we had the version with just one parameter, in this case the right-hand side, implementing the operator plus method in the player class for the left-hand side. So this is implemented as member. So we have seen it before, but it's also possible to do it with two parameters. As we've seen for the output operator, we can do something like this. We could implement it outside of the class, having the left-hand side a player, the right-hand side a player, doing the calculation, and declaring it as friend. This would also be possible, just showing you, that both are doable, both are valid, but I think for this example, the first version as member is the preferred one. So whenever the left-hand side object is of a custom-defined class as player, you can implement the operator overloading within this class. But whenever the left-hand side of an operator, as we've seen here for the output operator, is not custom-defined, you have to do it with this friend version outside of the class. Okay, then again, the syntax in more detail when we do it as friend. The first part is the same, so we have the return type. This could be integer, this could be player pointer, this could be whatever, this could be OStream, as we've seen before. Then which operator we want to overload. Then two parameters instead of 0 or 1. We have the left-hand side and we have the right-hand side, and we do some calculation and returning some stuff. And yeah, this is the left-hand side, which is more or less the whole difference between these two versions.
So basically, it is the same.
Yeah.
But when you use classes, the left-hand side is implicitly taken from C++.
Yeah, correct.
That's the difference.
So the next Slido quiz. In this case, there's no code, but it is a multiple choice question, which statements are correct. And there are 5 statements about operator overloading, about this, more than 20 again, so I think we can go ahead and check the solution for this question. Yeah, and there are 4 correct ones and 1 wrong statement. So the correct ones are that there are operator overloading functions that take 2 parameters, as we have seen, for example, for the output operator, which is for sure correct. The return value of an operator can be void is also correct. We've seen this for the pre-increment operator. Inside the overloading function, this is always the left operand, which is also correct. We've seen this in the player class operator overloading of the plus operator, where we use.
But I have to say that this always makes me a bit, because when I write it outside a function, it's still operator overloading, and there is no this there.
Yeah, correct. Yeah. So if there is a this,
So I would say that this is not always, but yeah.
if there is a this, it's always the left.
If
one.
it is there's this, it's always the left one. Yeah.
Okay. And the last correct one is that the assignment operator is implemented for classes by default, which is also true. And wrong is that unary operators have a left and a right side. For sure, unary operators do not have two sides. There's just one object.
There are some funny operators we could overload.
Okay.
So we showed you most of them very, very useful ones. What you also can do is, for example, you could overload the new and delete keyword. I don't know why you would do that, but you can do it. I would also have no idea why you should overload the array access. So basically what you can do is you can access an array, but then print something out or multiply or whatever. A very funny one is you can overload function calls. I think we have an example for that.
We'll see that.
There are some operators which are maybe luckily not able to override. For example, the scope operator, the dot operator, or also the ternary. This one is complicated enough. I think if you override this, wow, that would be too much. Yeah.
Okay.
But function calls is a very funny one.
Yeah. So we have an example prepared. We have here an adder class, and in this adder class, we override the function call, so to say. So this two brackets here. And in this case, we take two parameters, A and B. And the result is then A plus B in this case. Two integers, result is an integer. And how can we use this? We can create an object of the adder class, and then we can use this object and call this operator on this object, which then looks like an add function.
Yeah, so basically you can use objects as functions.
Yes,
Yeah.
and we then pass two integers, and then those integers in this case get added.
So luckily in this case,
Luckily, yeah.
it makes sense,
Yeah.
because you implemented the right way. But let's say you call your object not add, but I don't know, subtract,
Yeah.
divide, whatever.
Or do some other stuff here, then just
print something out,
Yeah.
or whatever. So can be very confused if you do it like this.
So I think as a suggestion, if you do not want to do some funny stuff, don't do that. At least don't do it in the practicals.
You will confuse your team members,
Yeah.
of course, yeah.
Okay, to wrap it up, the operator overloading, we can change the behavior of operators, as we've seen, at least if we have on one side a custom defined object. Most of the operators can be overloaded. We have shown you examples which one can be overloaded. You have a detailed overview of this at this link here. Some of the operators are overloaded by default, as we've seen for the assignment operator. And again, this is only possible if one of the side, at least one side, the left-hand side and or the right-hand side, is an object of a user-defined class. So I can't overload an operator where both sides are integers, for example. Yeah, so we've seen different implementations, so a unary version and a binary version with just one operator, and with two operators we have seen two different versions, the member version versus the friend version, where we declare just friend and the signature of the operator overloading method and implement it outside of the class, which is necessary for operators where the left-hand side is not of a custom-defined class, for example, as we've seen for the output operator. Yeah, the assignment operator should be deleted or implemented deep copy and not shallow copy. And yeah, you should implement it when it makes sense for you. Yeah, and when it's straightforward to understand. So again, the funny operator overloading stuff you can omit. And yeah, there are some use cases where it really makes sense, as we discussed before. And I think it's a quite useful tool.
Yeah, it is, yeah. And I think next time we will also hear in the practicals what you can do, funny things with operator overloading. Yeah, I think that was it from our side.
Yeah, that was it. Thank you for your questions and your attention. See you next week for the last lecture.